a function of y for your what? For your web. We clear? Okay. So QZ for your flange, the width is 0.16. The depth is 0.02. The y bar is equal to 0.035 minus by 0.02 divided by 2. Okay. And then plus, okay, plus, now we are going to consider the web. The web we have left and right, which is 2. The width is equal to 0.02. The depth is equal to what? Now it's equal to 0.015 minus y. And then the next one is equal to 0.015 plus by y multiplied by what? By half. Can you all see the trend? Yes or no? You take the upper limit. That's why you need to play Nintendo. You take the upper limit, you minus y. You take the upper limit and you plus y, then you multiply by half. Are we clear? You can't go wrong. Okay? Then from here, this will be equal to the first set of value, 0.035 minus 0.02 divided by 2 times by 0.02 times by 0.16 is equal to 80 times by 10 to the power minus 6 plus 0.02 times by 0.15 times, 0.02 times by 0.15 times by 0.15 is equal to 4.5 times 10 to the power minus 6. And then the whole thing will be minus by 0.02 y squared. Okay. How do we know this is right? Yes. Yeah, you plug into this equation over here. You plug in, not this equation. You plug into this equation over there. You should get what? What you get? You should get 80. So if now you plug in y is equal to 0.015 down here. So 0.08 times by 0.015 times by 0.015. 98 power minus 6 minus you get 80. Okay, so you can check again. Are we clear? If this value don't match 80, there's something wrong. Okay, always find places that you can what? You can check. Not just for this subject, for any subjects that you do that. Okay, make sure you check. So this will be equal to 84 times 10 to the power minus 6 minus by 0.02 y squared. So from here, once you got this, the next one is your shear xy as a function of y. So now your v is 90 times 10 to the power 3. Your I is equal to what? 5.813 times 10 to the power minus 6 multiplied by what? Multiplied by 84 times 10 to the power minus 6 minus by 0.02 y squared. And then now you divide by thickness twice, or the thickness you already know already. The thickness you put down here is equal to what? 0.04. Okay. So that's why use that thickness value immediately. Okay. You know there's left and there's right. The textbook shows something different. Don't learn from the text. I mean, not the textbook, the solution manual. Learn what I teach you. Are we clear? The solution manual just say, oh, we just take half of this and keep on half in the end. Confused like crazy. So this will be equal to 90 power 3 times by 84 power minus 6 divided by 5.813 power minus 6 divided by 0.4 is equal to 32.513. I'll do it again. Yep. Then minus by so you get 7.741 times 10 to the power 9 y squared. Do you see something interesting now? I want you to focus on the what? I want you to focus on the 7.741. Did we get 7.741 at the top? Yes or no? Right? So another trend that you can see, I mean, because this is the first question, you all don't see it yet. I've been doing too many. I see too much of this. The second order polynomial equation, the coefficient are the what? Are the same. You see that? Okay. The second order, okay, second order coefficient are the same. Okay. Understand? Okay, so if they are the same, you're good. How we get there, the numbers are different, yes or no? Right? The numbers are different, but yet it's the same. Now, remember what I told you guys, that the first moment of area cannot cross the what? Cannot cross the centroid, right? I'm going to prove that hypothesis again. Now, we are going to analyze, determine the distribution now at the where? At the bottom. The answer, you'll be surprised. Okay, now let's consider the distribution at the bottom. Okay. Now we are going to do this. Okay. Now what we want to do now? Maybe I don't make myself clear, but we are going to do this. We now want to find the distribution of this entire, or we want to find now our y variable is doing this. And then this is our what? Our y bar. Okay. So from here, we now know that this is 0, y, and it will go until 0.065 meters. Okay. We do that because the thickness is equal to what? Twice of what? 0.04. Yes, 0.02. Twice of 0.02. So this is equal to 0.04 meters. So from here, we're going to calculate our first moment of area, QZ, as a function of y. So this will become, so the width is twice, sorry, left and right, okay? The width is 0.02. The depth now is what? 0.065 minus y, bracket 0.065 plus y multiplied by what? Multiplied by half. So this will be equal to 0.02 times by 0.065 times by 0.065. This will be equal to 84.5 times 10 to the power minus 6 minus 0.02 y squared. Does this look familiar? Does this number look familiar? This number over here and this number over here are exactly the what? Are exactly the same. That is why first moment of area cannot cross the what? So you look at it for textbook, you get it for crazy guys that has nothing to do on Saturday morning, 1 o'clock, you guys have from here. My strategy is if I take 1 year to learn something, then I can impart the knowledge and you can learn this within 2 weeks. I do. Okay. Then the no class. Right. Any questions from here? So you have to have the confidence whether you take from the top or you take from the bottom, the answer will be and shall be the what? We clear. So if you look at this now, if I ask you to look for the distribution for the wet, the vertical section, right? You take from the top, you take from the bottom, the answer will be the what? Answer will be 2. Right? I don't want to go any further because I will just write this down. It's self-explanatory. Where the shear xy as a function of y is equal to 35.513 times 10 to the power 6 minus by 7.741 times 10 to the power 9 y squared. You just put in the same numbers. Are we clear? Okay. Now, next, we go into composite material. Okay. I've posted this on Avenue to Learn. Okay. And the concept is not any different, right, from bending moment. Okay. And this is the solution. Why I put the solution down there? Because I want to teach you how to use the solution manual. I repeat again, I want to teach you how to use the what? The solution manual. Okay. So this is example number 2. And it's really, really easy. When I say is now, listen, the toughest part of shearing stress is over. This is so straightforward. You still apply the same rules as before. Okay. Look over here. The steel bar, okay, and an aluminum bar are bonded together as shown to form a composite beam. Knowing that the vertical shear is at 4 kilopound, okay, so this V is equal to 4 times 10 to the power 3. And the modulus of elasticity is 29 times 10 to the power 6 for steel. And for aluminum is 10.6. Determine the average stretch in the bond and the maximum shear in the beam. Okay, so this is the solution. Okay. When you have a solution manual like this, to really see whether you understand the concept is the value that are most important are what? Is this and this. How they get there, don't try to figure out. If you try to figure out, okay, it takes longer than apply what I teach you. Are we clear? So if you look at the solution, they use what? Aluminum as the reference material. Okay. Me being like Evans, we like to do something different. What is the difference we're going to do? We're going to use steel as the what? This is how you should study. Do something different and do something crazy and don't watch YouTube and social media. Focus. Are we clear? I'm not saying that you are. Yes, sir. Hey? What? Oh, they are. Hey. Thank you for the marketing, yeah? They are the best, man. But it's always improving. You will watch my YouTube videos. I'll take about 6 weeks to teach this. Now I compress it to what? 1 week. Okay? Because I finally see the light. Okay, I was too long-winded. Too much jokes. So I'm going to use steel as a reference material now. So when this is the case, so we do something different. The answer has to be the same. What's the purpose of doing this? Is to build confidence. Are we clear? It's like Chinese cooking. When you don't have confidence in your cooking, what do you put? Chinese people, where are you? You put oyster sauce. So that is N for steel. N for aluminum is equal to 10.6 divided by what? 29. So 10.6 divided by 29. Remember, if you have no confidence in your cooking, all you need to do is put MSG or oyster sauce. Are we clear? Then everything tastes like Chinese food. Okay. Right. So from here, okay, from here, now you can look at the procedure. The procedure, okay, you find second moment of area. We are going to do the same, okay? So for this case, we need to identify the what? Centroid and I. Okay, for this case, I'm going to call IZZ. Coming back to here, this is our transformation Y, and this is our what? Our Z. Okay, so from here, we divide them to section. So the section I'm going to have, like what we did before, we have a section of steel, we have a section of aluminum. Then the next column I'm going to have is N. So for steel is 1. This will be equal to 365.517 times 10 to the power minus 3. Then you have your N width multiplied by depth. So it's the same concept. The N over there is moving your what? Your thickness. Are we clear? The depth is still what? Constant. I repeat again. The depth is still what? Constant. So it's 1 multiplied by the width, which is equal to 1.5. And the depth is equal to what? 2 inches. Okay. So this is equal to 3 inches. Over here, this will be equal to 365.517 times 10 to the power minus 3. The width is equal to 1.5. The depth is equal to 1. Okay. Yes. Okay.